Hi everyone. In this video we will talk about phase change diagram. So it is the same concept of heating and going through melting, freezing, condensation, vaporization. But in the heating curve we were only talking about the temperature change. So there was no second variable. It was only temperature, and we discussed that how energy will change as we change the temperature. But in phase diagram, we have two things. We have temperature on our x-axis, and we have pressure on the y-axis. So now we will see that if we change temperature and pressure together, what kind of a difference does it make? So if I have a substance that I start from 0 degrees Celsius or 0 atmosphere pressures, it's a unit for the pressure. And then as I increase the temperature and I increase the pressure, okay, so I go from negative 200 and I'm going to, let's say, go above 100. Okay, I hope I can draw a straight line. So it's negative 200 and you're going up, it's a 0 right here, and then it starts going positive. So I'm increasing the temperature, at the same time I'm increasing the pressure. So as I increase the temperature and the pressure beyond certain point, the, we will see all three phases, because in this phase diagram, the first section, if I have A, B, and C, then the first section is always solid. The second section is always liquid, okay, and this one is always gas. So you have to remember that whether it says A, B, C or A, B, C, doesn't matter, X, Y, Z, it has to go from solid to liquid to gas. So what I was saying, that if I increase the temperature and I increase the pressure, what's happening here is that the solid is being converted into liquid. Okay, so the substance is going through melting. Okay, and if I keep increasing the temperature, okay, then it will go from liquid to gas, which is vaporization. And when I decrease the temperature, on the other hand, so I'm decreasing the temperature and I'm decreasing the pressure, it will go through condensation. Okay, because it's a gas to liquid, it's a condensation, and then liquid to solid, it's freezing. So decreasing the temperature and decreasing the pressure, it works backward. Increasing the temperature and increasing the pressure, it goes through melting and then vaporization. But if I decrease the temperature below this point, okay, here is the point. So if I decrease the temperature and pressure below this point, you see that we completely skip the liquid stage. So when we skip the liquid stage, what is happening here? If you notice, the only thing happening is that your solid is being converted straight into gas. So when solid goes straight into gas, that process is called sublimation. Okay, and if I decrease the temperature again, this is called deposition. So basically the point here is that we will completely skip the liquid part. The temperature and pressure have to go above a certain point to count that liquid section in. Otherwise it will go through sublimation or deposition. But the rest of the story doesn't change. The kinetic energy changes as we increase the temperature, it decreases as we decrease the temperature. But what is this point? The point that connects the solid, liquid, and gas is called triple point. Triple point means it is a point, or it is a temperature and a pressure at which all three states of matter exist in equilibrium. Okay, means at this temperature, which is pretty much 100 degrees Celsius, and at this pressure, all three states of matter, solid, liquid, and gas, exist in equilibrium. What that means is that they are like you're converting solid into liquid, it's melting, vaporizing, condensing, freezing, all at the same time. Okay, so here is again phase change. You have solid, liquid, and gas, and here you have a triple point. So we have vaporization, condensation, freezing, melting. You have to memorize sublimation, and here is a sublimation that goes straight solid into gas. Okay, and deposition, gas into solid. So the sublimation and deposition happens only below this temperature and below this pressure. Okay, above this it's all three phases. Then there is a triple point. Okay, triple point is a point at which all three states of matter coexist or exist in equilibrium. I was using the word equilibrium, EQUI. Equilibrium means they coexist, exist together. And then there is a critical point. Critical point means it is this point. This is called critical point. Okay, it's right here. Critical point means that beyond this temperature you cannot liquefy a gas. Okay, which is it is this point right here. That beyond this temperature you cannot liquefy a gas. So we have a triple point right here. Okay, we have critical point right here. We have solid, liquid, and gas. You should know it's melting. Okay, it is vaporization, then it is condensation, then it's freezing, it is sublimation, it is deposition. So you should know all three phases. You should know how we increase the temperature and the pressure and what kind of changes we get. We need to take all these notes. You need to know the definition of a triple point. You need to know the definition of a critical point. Okay, now so the rest is a practice that we will do in class together. So up until now, your homework was only to take notes. So you should record all these definitions and take notes, and the rest we will practice in class. Thank you, everybody.